Thank you.
Hi everyone, my name is Pablo. I'm the founder of a company named Zenva, and since 2012 I've been teaching online how to make games with different technologies, and my main project at the moment is a comprehensive course on VR game development, where people are learning how to create 12 interactive experiences. And while I was preparing this presentation, I thought, well, it's going to be about 360 content, photos, video, and why am I then using PowerPoint as part of my pitch? I was going to say you guys are innovators by being in an event like this, and you're interested in problem solving, and then why should I be using something like PowerPoint? So I put together a little example in Unity, and I did the worst thing you can do, which is basically move PowerPoint to move something bad to a new media. So we're going to do this in Unity. And I would actually rather be on the beach, so I thought at least I can be on the beach in Coolangatta on a virtual world. So we're here in a 360 experience. But let's go back to where we are now, to New Farm. So we're now in New Farm, and there's this dinosaur New Farm, which is just a sort of thing you find in the area. And voila, you've got the bad practice of bringing 360 content, bringing the bad stuff from 2D into 3D, the PowerPoint into VR. Woo! So let's start by talking about 360 photos. 360 photos are simply wide photos that cover at least 360 degrees horizontally. And when I first came across 360 photos, I didn't know how they were stored. I thought, is that a new file format? How does it work? And it turns out they're just simply JPG files, JPJ files. So I'm going to show you a couple of examples. And what's great about 360 photos is that all you need to take one is just any phone, and you can download the Cardboard Camera app, which is free on iOS and Android, and you can just stitch together a photo anywhere. So now, not all 360 photos I created equally. So I'll show you the one that I took with the Google Cardboard Camera. It has 360 degrees horizontally, but it doesn't necessarily have the whole sphere. Moreover, a lot of 360 cameras, such as this one, 360 Fly, have a blind spot. They don't cover the whole area. So when you are working, and when you are going to work in Unity with these photos, you need to turn them into, you need to fill in that missing space. And now you may wonder, how is it that we can store this spherical information in a rectangle? Well, we can ask this other dinosaur here, and he is going to tell us that there's something called the equirectangular projection. Pretty weird name, but we're all familiar with the world map, and that's exactly what the world map uses. So that is what we need. We need these images that have that are a rectangle, and the width of the image needs to be twice the size of the height of the image. So that is what we are going to need. So this girl here is going to tell us something, maybe something interesting, and she is going to say that exactly we need to do that transformation ourselves. So I've taken a few different photos here. The 360 camera photo that I took with the Google Cardboard Camera, I pretty much painted the missing areas with a color. Then with my Samsung phone, the Samsung Camera app actually does the whole sphere. It's called a surrounding shot. So that is the whole 360, both horizontally and vertically. And then with this 360 camera Dragonfly, when you actually take the photo, this is how it's stored. It's like a different format. It's a sphere photograph, but it has an option to export it as a rectangle, and then you can end up with something that's equirectangular. So the width is twice the height. That's what we need to work with these photos in Unity. So what we're going to do now is see what else we can learn about this. And it happens that in New Farm you run into these giant skeleton warriors, and this one's not being very helpful. It's actually coming towards me, so it's feeling a little bit creepy. And I think maybe we should just run away and go into 360 video. So I'm going to escape that environment. And now I'm back in Coolangatta, which is what I really rather be on a Saturday morning. So what about 360 video? For 360 video is video that is taken from also at least the whole 360 degree horizontal around you at the same time, which means we can't use our phones to stitch that together, because we wouldn't be able to get that at the same time all around us. So we need to use a 360 camera, and there are different options out there. So it is common that cameras will have also a blind spot. For example, this one, if we look down, that is a blind spot. So if you're interested in purchasing a 360 camera, take a look at how many degrees they have vertically, because not all cameras are created equally. And that is something to keep in mind depending on the project that you're interested in building. Now, what does this guy here have to say? It's the same thing that with images. We also need this equirectangular projection to work with these videos in Unity. And at least with this camera, the way that the video is originally taken is like so, but the program allows for an export as an equirectangular projection, and then we end up with something like that. So same as with the photos, a 360 video is just a video it's also in a rectangle in 2D, so it's not like a different type of file format, and it just uses that projection to represent spherical information. So now back in Unity, and I'm going to have a chat to one of these creatures, and he also says that for Unity we need to have the file in that correct format. And there's something important that we still haven't discussed, which is that all of these 360 photos and videos that I've shown you are not really 3D, because both eyes are seeing the same thing. And if you cover one of your eyes and then look at the other side, you're going to see that they see obviously different things, because eyes are placed in different locations in space. So that is what's called a monoscopic approach, when both eyes are seeing the same thing. And that's the type of media that you usually capture with your phone or normal 360 cameras. But then there's also the option to do stereoscopic, in which you would have basically 2 photos, one for each one of your eyes, or 2 videos, one for each one of your eyes. And there are at the moment very expensive cameras that can do that. And I know that other people are doing it with like 360 photos, and they use some sort of device to put them in different positions. So it can be done, but it's just more difficult. And so that is for this part of this is like the presentation. And now, since we have some time, and I know some teams are working with Unity and are going to use some of this stuff. By the way, all of this is already on GitHub, so I'll share the link as well, and it's being streamed to YouTube, so you can watch it again. Because what I'm going to do now is start with a new project in Unity and show you step by step how you can place a 360 photo or a 360 video in Unity. So I'm going to go here and go to a new project. And let's call this 360 demo. And it's quite easy in Unity these days to be able to show this media. So it's a great way to create all sorts of content, because it can be applied in training, education, health, in productivity, entertainment, tourism, anything really. So this is taking a bit of a little time to load. There we go. So it's preparing a new project for us. So the first thing I'm going to do is just save my scene. So I'm going to make this easy and quick. Just save it as a game. And we're going to start with the photos themselves. So I'm going to bring in a few files to Unity. All right. So the broadcast ended. Whatever. Let's bring in one of these files to Unity. So I'll bring this the new farm photo. So I'll just create a new folder in Unity and call that textures. And just drag the photo into Unity. And this is being a bit slow. So in that photo, what I want to do is set the way that the photo is imported to a cube. And the mapping, I have to select this cylindrical, because it's a equirectangular projection that I mentioned uses latitude and longitude. So we've imported our photo, and we're going to apply that. And what we are going to set up is something called a Skybox, which is what you can do in your games or experiences to have some distant landscape. And it is basically, think of a die, and there's basically 6 sides around you, and that is the sky. So this image is sort of projected into that Skybox. So you start by importing the texture like I did, and then you go and you need to create a new material. And this material will be that Skybox. So I'm going to go to Create, Material, and I'm going to call this 360 Photo Skybox. And then in Material, we have to pick something called a shader, which is a program that tells the graphic card how to display this on the screen, how to render this. So we're going to go to Skybox and pick the cube map. And we now need to drag that image to our Skybox. And so that gives us this, this is what our material looks like. So we got it here. And then the next step is actually quite simple. It's just to pass that Skybox onto your camera. So we have our camera here, and that's what we are seeing in the virtual world, in our game. And the camera needs to have a component added. So we're going to go to Add a new component. And I'm going to type in here Skybox. There's a Skybox component in Unity. So I'm adding that, and then I have to drag my material that I created. I have to drag that onto here. And there we go. So we've got now the, if we press play and we put this on a headset, we would be able to look around. Because once we are in the editor, it's a little bit hard to simulate, like we can't like look around. I'm just going to drop in a few script that allows me to do that, and that's in the demo that's going to be online. So that is just a piece of code that I already have that I made for this sort of purpose. So we're just going to drop this Zenva VR folder here, and then just put this drag camera script onto my camera. So all this does is really just being able to look around. So we've got that working, and we have now enough time just to show you the video part. And so for the video, I'm going to create a different scene. So I'm going to go here and create a new scene, which is going to be called a video scene. And the previous scene was the 360 photo scene. A lot of the other stuff you saw in the demo is going to be on the files you download. So then you can get the location pin and the panels. So you can use all that stuff. All right, so we're now on a new scene. And what we need to do here is bring in our video. So I'm going to create a new folder called that folder videos. And inside of that folder, I'm going to bring in that 360 video of Coolangatta, which is a place where I'd rather be in the weekend, and bring the equirectangular one. So that's all really you have to do. And now we need to, how are we going to show our video? What we're going to do is create a big sphere around us, and we want to project that video in the inside of that sphere. So I'm going to go here and add a new 3D object, which is a sphere. And I'm going to call this 360 video sphere, and give it a really big size. So it's like 300 meters on each dimension, so it's massive. And everything that we do, it happens inside of that sphere. So it is a really big sphere. And I need to set the Z property here, 300 as well. All right, so we've got that huge sphere. And what we do now is simply drag the video onto our sphere, and that creates a video player component. And we can make sure to have select, so our file is there, and then we can have play on awake, and we can have loop, so that this loops over and over. But then you'll see what happens when I press play. We can't see anything, and it's because the video is being rendered on the outside of the sphere. So there's one more thing we need to do, which is make our sphere render the video on the inside of the sphere. And for that, we need to bring in an external shader file. And a shader is really a program that tells the GPU how to show something on the scene on your game. And all this shader does, it makes the video render on the opposite side of the face of our mesh, of our sphere. it inverts the normal, if you're familiar with the 3D modeling concept. Basically, it's like you have a photo, and all of a sudden, you're going to show the photo on the other side of the photo. So I'm going to go and bring in that shader file. And so I'm going to drag in this shaders folder into my project. And so that's going to import the shader. And then I'm going to drag my shader onto my sphere, or into my sphere object. Oh, I have to create a material first. So I'm going to go at materials, create a new material. Let's call this flip normals material. Flip normals, and then this material needs to have this special shader that we brought. It's just under custom flip normals. Normals means the direction at which the material renders, and we're just flipping it so that you can see it from the inside. So we've created our material, and now I drag my material onto my sphere, and if I press play, I should be seeing now the video, and I can see the video, and it is playing, but it just looks very dark. So that's something else we need to do, is increase the light of our scene. And so I'm going to go to lighting options, settings, and then Unity has this like default skybox. We don't need that. So instead we should just set a color, and the color is going to be white. And if we press play now, we can see that now we have our video, and it's looking on the right resolution. And it has audio as well, so you'll be able to listen to the waves, although the wind made like a really strong noise. So the last thing I'm going to do is just bring in that same camera script so that we can drag look around. And so I'm dragging that to my camera, and now if I press play again, I can look around. And so that's it. Basically, that's the basics, and the presentation Unity project. You can find it all on the following URL. So I'll put it somewhere on GitHub. And feel free to download it and use it for your own projects. So where's this last thing I did? Here it is. It's all there, and so then you've got the location pins if you wanted to change between scenes, and you've got some other stuff like the model boxes and whatnot. So that's about it. It is again an invitation for you guys to use this kind of new media in different ways, and hopefully not bring the bad habits into VR. Try to do it in a different way. And also, if you're not using Unity, you can also use all these things like with the open web technologies that I think we're going to learn later today. So it's really a lot of new cool stuff that's up there for you guys to use. There's an extremely low amount of good applications and games on all the VR platforms, in my opinion. A lot of the times I've been there willing to spend money. I'm like, just please impress me. I want to be taken into a journey or have fun. And then you see just such few variety of options of games and apps. So it's really an open ground for you guys to come up with new applications for all of these cool things. So that's all. Thank you. If you have any questions, happy to respond. Any questions, anyone? So if you want to check the presentation, if you got a cardboard, just come around, because I've got it on my phone, or Gear VR also.
Yeah, a colleague of mine used a trick with these video spheres.
Yeah.
To get some like depth. Stereo vision. So he made it so that the video is similar to yours, that you're kind of close to the ground, but then you also have like something far away. So he just made it so that it's not a sphere actually, but it's more like a dome, that the ground is closer.
Yeah.
And then like far away parts are far. And I think that actually worked well. So when you look down, the ground looks
yeah.
like mirror. And
so it's like he's using like, she's using like, they're using two different videos? Is that it now?
One video, but just like change the shape of the sphere.
Oh yeah, that's really clever. Yeah, that's quite clever.
If that's like a known technique, because he just invented that by himself.
That's amazingly clever, because then you could have materials that are near you, and then kind of had the other half kind of transparent, and then you could have the other dome. That's really clever. And if you wanted to make it like really 3D, if you had the stereoscopic, what you have to do is the same thing I did, but basically put each one of the sphere in a different eye. So if you work with like for example, the Steam VR, you get the camera for each eye, and you would have to do the same thing twice on each eye. And like performance-wise, like I run the drawing, like the draw calls, actually quite efficient. It's like one draw call, it draws the whole thing at once. So that's also good, like even better than like at least for the photo, it's better than a normal Skybox if you have like the 6 images. It's 6 draw calls. In this case, it's just 1 because it's got the cube map. So yeah. Question?
That was my question. The same technique applied for stereoscopic. You just map it onto 2 spheres.
Yeah. And the way I did it with photos here wasn't with spheres, but you could also, like literally the same thing I did with the video, you could also do it with the photo. It's just another way of doing it. And then yeah, you could just have 1 on each eye. All right.
Got a question for
you,
which is, I'm afraid I didn't get time to actually see the majority of your talk.
That's all good. It's on YouTube. It's going to be on YouTube. So.
When you do render the sphere, are you doing it eye referenced or are you doing it world referenced?
So
is it locked to the world or is it's on?
Well, I placed it in. It is just a world reference, but I placed it in a distance so far away that the position tracking was, because position tracking doesn't really work with this kind of media.
I'd agree. So yeah. I've seen this used. I mean, obviously, when you've got the phone-based stuff, it's not doing room scale tracking. So
yeah.
It sticks with you.
It will be really strange because you're moving forward and like your surrounding stays there.
Any motion there works out really bad. Yeah. I've found as well world reference, drop it in the world, but set it up with a plane that you're standing on.
Yeah.
Just so that you've got something in your peripheral vision to ground yourself. So then actually moving around, even though there's no parallax in the sphere, actually seems to make it a lot more comfortable. So
you would use like a texture for the ground, and then you can move on that.
Well, not so much that. It's the stuff that I've got. It doesn't matter if you realise you're not standing on the ground properly.
Yeah.
So just a transparent disc, effectively, that you're standing on.
Oh, so
flattened cylinder or something like that.
Yeah.
Just gives you a grounded reference. So when you're moving around, you can actually you preserve something called your ego motion. You know how. You
Okay.
And I've just found that helps people who do find it a bit because when they want to move around, it's not going to move with them.
Yeah.
But at least that gives them something where they can actually see where their movement's going.
Yeah, that's really clever because then you would have a point of reference and like a bit more.
Which is really important for trying to stave off elements of that simulated sickness.
How big would you make this plane?
I only have a limited area to work walking. Yeah. So maybe 2 meters.
Oh yeah.
At most diameter.
Mm-hmm.
So yeah, that works out pretty well.
Wow.
All right. Thank you very much.
Thanks.